right, are there any questions? We are have our exam scheduled for Thursday, but I got some requests for changing it to Tuesday next week, which is okay if you want to do that. The test date. Is it all right? All right, we're going to change it then. I'll post an announcement. I'll talk about what we're doing today is something new. Actually, we are going to continue with the titration, but that's going to be after you finish this stuff, the new stuff. What we're going to do today is this. We're going to use a software package called Visual Mintech. Visual Mintech does equilibrium calculations using activities and solving simultaneous equations. And so what you're going to do is you're going to pick a homework problem, from the acids chapter, and solve it using Visual Mintech. And then pick a homework problem from chapter 18, KSP, KF type problem. Actually, you should do a KSP and a KF or something. Actually, it doesn't matter. So let's just keep it simple. We'll pick one problem from the acids, one problem from chapter 18 from your homework, so you already have the answer. Run it through Visual Mintech and then compare the output from Visual Mintech with what you got and then comment on it. Should I write this down, or do you think?
That was chapters ago.
You could just look at one of the problems. Pick one at let's see. Do you guys have Mastering Chem?
The textbook?
Yeah, Mastering Chem, you have the online text.
Mine's expired a long time ago.
Alright.
But I have the textbook.
Maybe you have your textbook?
Yeah.
Oh, yeah. Alright, this is the Visual Mintech lab. Have a stronger connection. Oh my God.
Yeah, I have little.
All right. For Visual Mintech, you're going to have to learn how to use the program. I'm not going to give you step-by-step instructions. Instead, you're going to look at what's available online and then figure it out yourself. Yeah, that's what's going to happen. People aren't going to write some kind of step-by-step manual just for you. Usually, you're going to have to look at some kind of online tutorial or the user's manual and figure it out yourself, as you progress. And so you might as well get used to it, because this is the normal way things are done, I think, and not the usual way where you just follow step 1, step 2. Okay, so you have to learn how to use the program. That's challenge number 1. And then we're going to do some calculations. All you have to do are 2 calculations. And so this is not difficult. An acid and or base, meaning titration, whatever. Any problem, I don't care, from chapter 16 or 17. All right, then you're going to have to do a KSP and or KF.
What did we close this before?
From chapter 18.
You're getting compliments.
Then what you're going to do is you're going to compare the output from Visual Mintech to
Why don't you know how to get in the damn program?
calculated.
It's okay.
Visual Mintech is a free, actually you can read this, but it's a free program that was developed by the EPA. To do solution chemistry. It's an extremely powerful program. They used it to model the cooling system on the space shuttle, other stuff. And so it's a program that's in current use today. It's up to date. All the KSP values are updated continuously. And so it's fairly accurate. So it's supposed to be easy to use. You can see if that's the case. I think most people can learn how to use it in minutes compared to other programs, which take many days to learn. All right, this doesn't take very long, so what I want you to do for the remainder of the lab period is to start on your formal report for the titration lab. You're going to start with the discussion section for the titration lab. Now, this is something you should have done for your synthesis lab, and not a lot of people did this, but you should show the calculations and discuss the calculations. For example, you know, the theoretical yield was calculated, and then show the equation. I think very few people actually did that, but that's normally what's done, and we do calculations. You don't just write the calculation, you have to explain the calculation. The same thing with the titration lab. You just don't show the graph. You have to analyze the graph, you know, by hand or whatever else, and then you have to describe how you're analyzing the graph. For example, I drew the tangent line here, or I did this, I drew the intersection, this is how I, or you try to avoid first person, but you don't have to. But basically, you're going to explain how you analyze each plot, right? And then from each plot, you're going to get a equivalence point, or maybe a pKa, whatever, and you're going to just talk about how you got that, how you determine that equivalence point, and then you're going to compare the equivalence points that you get from the 3 or 4 plots. You know, do they match? If they don't match, you better say something about it. You know, they're supposed to match, right? And so you need to discuss. If they don't match, what are you going to do? Are you going to average the 3 as a straight average? Are you going to throw out one? Or are you only going to use the first one? or the third one, you're going to have to explain that in your analysis. And then from that data that you got from the titration curves, you're going to determine the acid. And when you determine the acid, you have to, a lot of people say, okay, this is my acid, this was the best match, but they don't talk about, okay, how good was that match? And then not only that, how good was the match, what's the next closest acid in terms of maybe molar mass or in terms of pKa? And so I think, the formal report is very simple. All you're doing is you're just walking somebody step by step through the whole procedure, of how you analyzed it. And so the only complicated thing to this lab is if your data basically sucks and nothing matches very well, then it's a big headache because you want to redo the experiment, but you can't. And so what you have to do is you have to accept the data that you have and then best analyze it considering what you got. You can't go back. And that happens a lot in science. You get data, but it took too much time to accumulate that data. You don't have enough time to go back, and that's all you got. And you got to keep moving forward. So whether it's a great experiment in the sense that it was easy to identify your acid and you have good solid evidence for it, or not so great experiment where the data just was kind of garbage and you just got to try to analyze it the best you can. And so this is the value of having a formal report, because in the formal report you can describe the difficulty you went through in assigning your unknown acid.
When is that due?
When is this due? I was going to ask for a rough draft next week. At least, analyzing your curves and working at assigning your acid. So I was thinking I'm going to collect, I wasn't planning to collect any rough drafts for this one, but I'm going to collect a rough draft. So start working on working up your curves, working up your data, and just assigning possible acids to that. Hopefully you get an assignment by next week. Okay. And so let's turn in a rough draft. I want to see how you analyze your data. The written part, just do the discussion first. The discussion is going to be the hardest part to write, but it's not hard for a lab like this, unless your data is bad. If your data is bad, then it's very hard. All right, any questions?
When, Thursday next week?
Yeah, let's make it Thursday next week. Let's have, if you came in late, what was it? The exam, due to multiple requests, I'm going to move it to Tuesday of next week. If that adversely affects you, let me know. All right, so do you guys know what we're doing? All right. Good stuff.